Hello everyone, welcome to another quick tutorial on 3G 4G channel. As always, the slides can be downloaded from our SlideShare channel. We value your feedback, so please let us have any comments you may have in the comment section below. We also appreciate you subscribing to the channel and also giving us a thumbs up or thumbs down depending on how you feel. So please do provide a feedback. So this video is an updated version of a video we made earlier on 5G network architecture options. This one has more clarifications, a bit more technical details, and it also looks at what different operators are planning. So how did this all start? Back in September 2016, which is already 2 years at the time of making this video, Deutsche Telekom created a presentation to show how many different architecture options with 5G are possible. So they had 8 options in total. That presentation is considered as gold standard, and everyone else in the industry took the numbering from there. I've created a blog post on this, which is provided in the references. Now the picture from KDDI is building on top of that Deutsche Telekom presentation, but it has some additional options like the 3x and the 7x. We will look at what these axes are when we look at these options in detail. So let's start with option 1, which is the legacy 4G LTE connected to EPC. This is already existing but had to be shown as the rest of the options follow this one in numbering. Here I also mention the two terms SA and NSA. Standalone, SA is standalone, is when one radio access network or RAN connects to one core network or CN. Non-standalone, on the other hand, has two different radio access networks connecting to a single core network. So in case of NSA, one of the RAN has to connect to other RAN for signaling and optionally data. Hence the term non-standalone, as it cannot be deployed by itself. Option 2 is where the 5G new radio or the G node B connects to 5G core. This for 5G is similar to what option 1 is for LTE. So in 5 years time, most of the 5G deployments would be this way. This kind of deployment allows an operator to take full advantage of the 5G system. So if you don't know what 5G system is, you should look at the terminology video in which I explain the 5G system. So full support of 5G applications and services including enhanced mobile broadband or eMBB, ultra reliable and low latency communications or URLLC, and massive machine type communications MMTC would be possible with this option. This option also makes advanced features like end-to-end slicing possible. So of course the real challenge is that if you want the benefits of 5G, you have to do deployment in not only one band but also in different spectrum bands. So this is going to be a big challenge for many operators because you would need a new spectrum or possibly recycle or refarm the old spectrum. So if you look at any of my recent 5G presentations, I explained this concept of different bands, the coverage layer, the capacity layer, and the high throughput layer. The final standalone option is option 5. Now this is going to be sometime in future when the next generation E-node Bs or the ng-eNB Bs will connect to the 5G core. So like the current E-node Bs connect to EPC, but in this case the E-node Bs will be upgraded to next generation E-node Bs and they can then connect to the 5G core. So this will allow the LTE nodes to continue supporting the legacy devices and at the same time connecting to 5G core network. So the operators can get rid of their existing 4G EPCs. So I thought before we start looking at the non-standalone or NSA options, let's understand some NSA terminology. So the concept of dual connectivity was standardized as part of Release 12. This was for small cells only. The idea was that a user equipment or UE or a device or a smartphone can connect to two cells or eNodeBs at the same time to exchange signaling and data. So you may be wondering whether this is like carrier aggregation. So it's not. So what you have to understand is that in case of carrier aggregation, both the cells are part of same hardware like a baseband unit, right? So there is a common scheduler between both the cells. In case of dual connectivity, the cells are on separate hardware, so they need a backhaul between them. So the messages in between them are exchanged over X2 for 4G. So you can see this from the picture, which is from 36 3GPP-TS 36.300. The node that is connected to the core is the master node. This node exchanges all the control plane messages with MME. The secondary node sends all its control information to the core via the master node. When it comes to user plane, the secondary node can send the information directly to the serving gateway via master node, uh, or it can actually send it via the X2U so whether it can send directly via the S1U to serving gateway, or it can send via the X2U which is to the master node, and the master node can then forward it to the serving gateway. So this will depend on configuration. If the user path is available right from the secondary node to the serving gateway, then S1U could be used. Otherwise, X2U would be used. So now let's look at the same diagram which we saw before from 3GPP TS 37.340. So here we are looking at multi-rat dual connectivity. So if you think about it, in previous slide we looked at single rat dual connectivity, right? Because both the cells belong to LTE. Now in this case, one of the cells belong to LTE and the other one belongs to 5G. So this becomes like a multi-rat dual connectivity. So the other thing to note here is like in the LTE case, the control plane for the secondary goes via the master node, whereas the user plane for the secondary node can go either directly to the core or via the master node. So we will look at this in the next few slides when we look at the different options. So the first of the non-standalone option is option 3, which is defined as NSA LTE assisted NR, right? So LTE assisted new radio connected to EPC. So in standards, it is also defined as EN-DC or E-UTRA New Radio Dual Connectivity. Within option 3, there are three different sub-options, 3, 3A and 3X. So the main difference is that in option 3, the sub option 3, there is no direct connection between the G node B and the EPC. Okay, so all the data flows through the E node B. This means that the E node B hardware upgrade would be required, will probably be required, because there will be a lot more additional traffic that needs to be handled by it. In option 3A, there is a S1U connection from G node B to EPC, but there is no X2U. So the advantage of this is that the traffic generated by new services can be handled by the new radio, while only the signaling goes through E node B. So there is of course probably a need to upgrade the E node B or the X2 interface anyway, to handle signaling. But otherwise, the EPC might need upgrading just to handle a lot more traffic, which is actually true for all the different three sub options. So in 3x is a combination, 3x is a combination of 3 and 3a. So both x2 and s1 interfaces available for the user plane. So the traffic can be split based on the capacity, the backhaul capacity of S1U. So option 3 is the most widely talked about option and will be the first option to deploy 5G. Um, so this way the operators, what they can do is they can use the new 5G new radio with their existing LTE infrastructure. As its non-standalone architecture, new 5G devices will be needed to support multi-rate dual connectivity to 4G and 5G. 5G hotspots will be created wherever new radio is available. So this is a very good way to actually start the deployment. So you start putting the 5G new radios wherever you have a bottleneck. So the existing LTE cannot handle the traffic. You start putting the 5G new radios, and you can start creating little coverage islands, like 5G hotspot areas. So this approach will also be used for fixed wireless access, right? So it will be used mainly for fixed wireless access and enhanced mobile broadband kind of applications. So once this is available and deployed, it is possible that there will be innovations and new applications and services will be created. We'll have to wait and see. One final thing to remember here is that in option 3, the 4G LTE node is still an E-node B. Okay, that means the existing E-node Bs will continue to work with the 5G new radio, and it does not need to be upgraded. In the other two non-standalone cases, which we are going to just discuss, the 4G LTE node will need to be upgraded to next generation E-node B, or ng-eNB. And what it means is they will have to be at least release 15 compliant, to work with those options. So the next option is option 7, which is the NSA LTE assisted NR, right? So the previous one was LT, again LT assisted NR, the previous one, but that one was connected to EPC, and this one is connected to 5G core. So the only real change here is, from compared to option 3, is that EPC has been replaced by 5G core. Of course, when you have the 5G core, that means instead of using the S1 connections from a 4G node to EPC, you have to use the new NG interface. Okay, so you have the NGC for control and NGU for user plane. And of course, to handle this new interface, the E-node Bs will have to evolve to next generation E-node Bs. So they will have to be at least 3GPP release 15 compliant. So like option 3, we again have three sub options with option 7. So you have pure option 7, which means that 5G NR has no direct connectivity to 5G core. Option 7A means 5G NR has an NGU connection to 5G core, but no XNU to connect the user plane to the next generation E-node B. And option 7X means there is a NGU to 5G core and also an XNU to next generation E-node B. So once option 3 is deployed and 5G is working well, then the E-node B can be upgraded to next generation E-node Bs, and the EPC can be replaced by 5G core. So from UE point of view, there would absolutely be no difference. Everything will work as it was working before. So here, as it says, at this point 5G will be driven by capacity needs rather than coverage. So in the previous option 3, I told about, like, you can start creating little coverage islands by putting new radio. So this assumes that 5G is now available sort of everywhere, and what you need to do is you need to handle a lot more capacity and a lot more traffic. So it would make much more sense, rather than keeping on upgrading the EPC to handle more traffic, you just put the new 5G core, which would probably be designed to handle a lot more traffic. So the final non-standalone option is option 4. So here the main difference compared to option 7 is that the new radio is the master node and the LTE is the secondary node. Okay, so remember in the last one it was the LTE master node and the new radio secondary. Here it's basically The new radio is the master and LT is the secondary. Now there are two sub options here, 4 and 4A. Okay, so in option 4, in the sub option 4, the next generation E node B is connected to the 5G core via the G node B. So there is no direct connection between the next generation E node B and the 5G core. On the other hand, in option 4A, there is a direct connection between the next generation E node B and the 5G core for user plane. And there is no need for option 4X here. So if you remember, when we discussed option 7, we discussed that the only difference with option 3 was that core was replaced from EPC to 5G core. In this case, it's the same as option 7, but the option 7 LT was master, 5G was secondary. In this case, 5G new radio is the master and LT is secondary. The operator can use this approach if they are confident with this approach and want to transition to 5G system sooner rather than later. So another option, another approach would be that the operator has tested option 7 and everything seems to be working smoothly. So now they can transition to option 4. So this may sound simple in theory, right? But it would be very difficult in practice. So this slide uh, shows a summary of all different deployment options, all the different deployment options that are being discussed, because there are actually more options, but they have not been mentioned here. So as you can see at the bottom, there are a few different migration strategies that have been discussed in standards and by vendors and operators. So as mentioned before, the initial deployments will be option 3 and maybe option 2. So there is only one major operator talking about option 2, which is China Mobile. So again, their roadmap is not very clear, and it's not very clear. The standards are not fully ready. They will be ready soon. So most likely we will only see option 3 initially. So from option 3, one of the migration paths is option 7 and option 5. Other migration path is to continue having option 3 and also deploy option 2. Again, another migration path from option 3 is to move to option 4 and option 2. So the point I want to highlight here is that there are different migration strategies and each has its own merits and drawbacks. The vendors, software designers, etc., they have to cater for all these different possible scenarios. There are also going to be a few issues during roaming and handovers between different operators. These things will probably take a while to iron out. Now, before we look at different approaches by operators, um, I want to just let you know that there is a GSMA white paper called The Road to 5G Introduction and Migration. The link is provided in the references in the end. So you can download and study these options which I talked about a lot more in details. Of course, the standards will give you very in-depth detail, but if you want a slightly in-depth, more in-depth from this video or the presentation, you can actually look at the GSMA white paper. Now, in that same white paper, which I've just mentioned, there is also mention on how the South Korean operator KT plans to move between different options. So as you can see, they start with option 3. Then they will probably move on to option 7 and option 2. And finally, everything will move to option 2. Now, because South Korea is one of the most advanced nations with the most advanced technology, so they can actually afford to have a complete 5G coverage in the whole country and move everyone to 5G. This strategy might not work everywhere else. And again, this is assuming that 4G basically would be closed down. But then you still may have 3G. So I think they have closed down their 2G networks anyway, or they are just about to be closed down. So this strategy may work in South Korea but may not work everywhere else. So another South Korean operator, LGU Plus, they have been discussing different migration options as well, but will only deploy option 3 first, and then they will decide the way forward. The Japanese operator KDDI, they plan to move to option 3 and option 2 later on. They haven't actually mentioned about any other options from what I've heard. Samsung is suggesting that the best way forward will be option 3, then option 7, then option 4, and then finally option 2. Okay, so this is similar to what I mentioned earlier. Ericsson's suggestion is option 3 initially and then option 2 when the 5G core is ready. Now, note that when I'm talking about option 2 being deployed, option 3 still exists. Because I mentioned many times about option 2. So unless you are planning to switch off the complete 4G, right, or basically create an option, use one of the options for LTE to connect to the 5G core, option 3 will still continue to exist in many cases. And the operators, in many cases, the operators will also keep option 1 active, because if you have an LTE network, with some LTE users who continue to use really old devices or phones or something, right? So you continue to use that. And if you think about it, in a way, option 1 can become like a subset of option 3. Telefonica hasn't said anything except for option 3. So option 3 is going to be their preferred option, and then later on they will decide what to do. This slide from Professor Andy Sutton from BT is actually provides a lot more detail. So BT is thinking about option 3x initially, and then later on going to option 7x. So then this will evolve to option 4 and eventually option 2. So if you think about it, it's similar to the option that Samsung had proposed, and quite a few of these vendors and operators have this approach in mind. And here is the final view from MediaTek. Now you have to remember that MediaTek makes chipsets that go in smartphones and other devices. Their view from standards is that it makes much more sense to have option 3 and then option 2. So in future option 3 can actually further evolve to option 7 and option 2. Again, they are also asking questions rather than dictating what approach networks should take. So this is some reading material. If you want to dig deeper into this topic, you can actually follow the links. And of course, there are standards. I haven't provided the links, but I've provided the numbers earlier on. So you can actually go to the 3GPP website and get those standards as well. So we hope that you liked this short video on updated 5G network architecture options. As always, feedbacks, comments, and suggestions are welcome. Thank you.